screen. Let me make sure it's on the right slide here first. Okay. Are you all able to see my title slide here? Okay, great. Thank you. So I wish that was such a great story of a reintroduction program that's been successful, and I wish that I was continuing the good news with this talk, but unfortunately, I've got some bad news to share about northern long-eared bats in eastern Nebraska and in parts farther east throughout their range. So this was a project that I've been working on with Keith Geluso at University of Nebraska Kearney, Trish Freeman and Cliff Lemon at UNL, and also Game and Parks. Mike Fritz was involved early on, and then Sean Dunn, and U.S. Fish and Wildlife Service as well. And so we began, we got involved with the continent scale effort to track the spread of this fungal disease, white nose syndrome, in hibernating bats in 2014. So today I'll present a summary of that research and then take a closer look at northern long-eared bats and what we know about them in Nebraska. So, oh, and I should say, most of the nice photos in this presentation were taken by Eric Fowler. He did a story for Nebraska Land. And so the other photos that aren't so good are mine and students of mine too. So just a little background on bats in Nebraska. All our bats here are insectivorous bats, so they're insect-eating bats, but we see two general lifestyles in our bats here, although some can do a combination of both. But some species are migratory, like this hoary bat. And so they're tree roosting bats, and they'll spend summers in Nebraska and other places as well. And then once temperatures start to get cold, they will migrate south and continue to be active during winters and feeding on insects. And then we have other bats in the state that are hibernating species, like this tricolored bat, who will remain here all winter long, and they'll find a place with a fairly stable temperature. We don't have many natural caves, at least that we know about in Nebraska, but there are mines in certain areas. Some can even use houses or storm sewers, and they will go into these hibernacula, stay there throughout the winter. They'll lower their body temperature and their metabolism, and they'll live off the fat that they stored up in the summer and the fall as they were foraging on insects. So many of you might be familiar with this disease, white nose syndrome, that was first seen in a cave in New York State in 2006, and it grows on the surface of bats. You can see it, the white growth on the muzzle, and then on the arms of the bats, the wings, the ears even. And this fungus mainly impacts hibernating bats. And so here's a group of bats that are hibernating, and when they have this fungus, they'll wake up more often than bats that don't. And when they're aroused, they get in the cycle of using that stored energy and becoming dehydrated. And there's some physiological changes with their blood chemistry, and they continue to arouse, and they'll use up all their stored fat. So it was seen in the eastern United States in 2006 and years after, large numbers of dead bats outside of cave entrances in January and February. So these bats are leaving to go look for insects and water, and there's nothing available, right? There are no insects flying in winter at that time, or few, and water's frozen. And so these bats were dying in really large numbers. So since this was identified, and when it was first found, it wasn't known what fungus this was. And so researchers got to work, and they identified the fungus as a relative of decomposers, and one that impacts bats, and it doesn't seem to impact other species. But it was then identified that this fungus is present in areas of Europe and Asia as well. So it's thought that it came to North America, likely by a person incidentally who went into a cave, possibly in Europe, and then came to North America and spread the spores of the fungus. But once it got a hold in New York in 2006, within 4 years, it had spread to many areas of the Appalachian Mountains. It had spread north into Canada. It had spread into Missouri even by that time. Just to show you a couple examples of through the years, this is 2014. And here we see it in most places in widespread in Missouri, including near Kansas City. And this is the year we joined the effort and started sampling bats in Nebraska. In 2015, we see it's present in Nebraska now. It was at that time the farthest west the fungus had been detected. And then in 2017, it's in Texas, and it jumps to Washington State. And then in 2019, it's throughout many states in the Great Plains, North Dakota, South Dakota, Kansas, Oklahoma. It's in Wyoming, and now in California as well. So by 2012, it was estimated that 6 to 7 million bats had died from this fungus, and so that number is likely much, much larger now. And we and so it's not found on all bats, but here's just a list of 12 species that are known to be diagnosed with the disease and actually have mortality from the disease. And the ones that are highlighted are those that are found in Nebraska. So 6 of the bats we have here are known to have or get white nose syndrome. There are also species that carry the fungus but haven't been shown to die of the fungus as of yet, or get the disease from carrying the fungus. And so some of those species are local bats as well, or we find here in Nebraska. So one species that seems to be very highly impacted by this disease is a northern long-eared bat. So I want to focus a little bit more on this species here. It was one that we had in our minds when we started this project, because we knew from early on in the eastern United States that this bat had shown pretty significant declines from white nose syndrome. So northern long-eared bats are more of a northeastern species in the United States and Canada. They're found on the East Coast. They range to the Great Plains in the United States, and also farther north and then west to British Columbia in Canada. A study that was done 5 years ago or so in the eastern United States, they looked at over 400 hibernacula in some eastern states, and from that they revisited these sites. So they did population estimates in these hibernacula, and they revisited them after white nose had been there for several years, and they found at almost 70% of these sites the northern long-eared bat was totally gone, so locally extinct from those hibernacula. Other bats showed declines as well, but none were as drastic as the northern long-eared bat. So as I said, we started sampling in 2014. So I'll show you some maps of our efforts here in Nebraska, and I'll explain all the black dots and the blue dots on this map in a little bit, but I want you to focus on the big gray circles here. So when we started, we had access to 2 mines in the state, one in eastern Nebraska, Raven's Nest Mine, and one in Greeley County, which is called Happy Jack Mine. And from that sampling, we had no positive results. So all bats we sampled were negative for the fungus. In 2015, we returned to these sites, and this is a picture of Raven's Nest Mine. So we would go in the mine and look for bats, and you don't see large clumps of bats in these mines. So there were relatively few bats using these mines compared to some caves out east. We never found more than 50 bats in this mine. So there's Mike Fritz searching for some bats, and if you notice, he's standing on a big mound. This mine scared me a little bit because there are always chunks of sandstone that were on the ground where we'd seen them on the ceiling previously, and so we didn't spend much time in these mines. But if we found a bat, we'd collect it and we'd swab it for the fungus. And so I'll show you what that looks like. But one thing we noticed is when we went into these mines, we saw big brown bats hanging from the ceiling. We saw tricolored bats, but we never saw northern long-eared bats hanging from the ceiling. But sometimes we found them in little cracks or holes. So here are two northern long-eared bats in Robber's Cave that are back to back and in a little drill hole in the side. And so we thought maybe we weren't getting a picture of the numbers of northern long-eared bats in these mines. So we also set up mist nets outside the entrances to capture bats as they were leaving. And we captured quite a few northern long-eared bats in the nets when we didn't see them in the mines. So here's Cliff Lemon taking a bat out of one of the nets. So we would process the bats. We'd look at sex and condition. We'd look at the wings of the bats. So I'll show you a picture of that. So this is actually taken from the summer on a bat, a young bat, because you could see the little cartilaginous plates that are translucent here. But this is a healthy wing. So we'd look at it with white light during our mine surveys. You wouldn't find young bats in the spring when we did our sampling. They wouldn't have been born yet, but this is just to show what a nice clean wing looks like. We'd also use UV light, and here's a wing of a little brown bat under UV light, and the fungus will fluoresce orange. So on this wing, you can see that the fungus is growing throughout the wing of the bat. Sometimes you wouldn't see any sign, any scarring or any sign, any orange on the wing, and the bats look totally healthy. So we'd take a swab sample, and then we'd send just run a sterile swab over the nose of the bat, and send that for DNA analysis of the fungus. And so that's what I'll report here is when we came back with positives of the fungus based on these DNA samples. So in 2014, we had all negatives at these two sites. We returned in 2015, and we found positive samples on big brown bats, tricolored bats, and northern long-eared bats at Raven's Nest Mine. In 2016, we got access to a couple additional mines, one really close by in Sarpy County to Raven's Nest, and then Robber's Cave in Lincoln. And bats were positive in Sarpy County, which is only about a mile away from Raven's Nest, so we expected that. But there was a little brown bat in this mine that was positive as well. So then at this time, we documented 4 species, but we hadn't seen any mortality from the fungus yet. In 2017, we sampled additional sites and found the fungus at those sites as well, including Robber's Cave, a big mine in Weeping Water, and up in Ponca. And I'll talk about the Ponca site in a little bit. This year, we also saw mortality. So we walked into we got access finally to a large mine in Cass County, and we found many dead bats. We picked up almost 50 dead bats in this mine, sent some away to the National Wildlife Health Center, and they were diagnosed with, they were necropsied and diagnosed with white nose syndrome. So this was the first evidence of bats dying from the disease in Nebraska. So we didn't go back and revisit the positive sites. We kept going to Greeley County, Happy Jack, to see if bats were ever positive there. And in 2019, we also went to a site, Smith Falls, and netted bats there. And I know of another effort going on with Ian Abernathy from University of Wyoming, who's been more broadly sampling bats in the Great Plains, and he sampled bats nearby as well. And both his samples and our samples were negative for the fungus there, and they continued to be negative at Happy Jack. And we didn't sample in 2020 though, so there's no data for that year. Okay. So that's a little summary of our sampling over the years. We also, as I said, we wanted to look a little bit closer at northern long-eared bats, and we wanted to figure out where they were hibernating in the state. We knew some were in these mines in eastern Nebraska, but we wondered that this map shows all the black dots are presence of the species based on an acoustic survey that we did. And the blue dots are absence based on that acoustic survey. And this data lines up pretty well with what we know about captures of the species in the state. However, I'm only showing eastern Nebraska. We do know this species is also, northern long-eared bats are along the Niobrara River, as far west as Sheridan County. So we know this is a forest bat, and it stays close to forests. And the red on this map show areas of forest, and you see that mainly along rivers. But what you'll notice is that even though there are forests along the Platte River and the Loup River and the Elkhorn River, we don't find this species in those areas.
Just a heads up, Jeremy, we have 3 minutes.
Okay, thank you. I better hurry. So, so we thought that the gray on this map shows areas of exposed rocky outcrops. And there's kind of a rough correlation you see with the distribution of this bat, this C shape on the edges along rivers where there's also exposed rock. And so we decided to use acoustics and put these near rocky areas in the state to see if we could find this species in winter. And just to give you a brief picture, you can tell based on the call and the frequency and the shape, you can distinguish different species with acoustics. So recording the echolocation calls of these bats. And so a northern long-eared bat call is on the right here under, and it's got a real big slope. It's a higher frequency call. But we needed to test this to see if it worked. So we put acoustic detectors outside of a mine where we knew northern long-eared bats were present and recorded one winter. And you see there's a big spike in March when it starts to get warmer and they're emerging. But what was interesting is throughout the winter, even though there weren't a lot of calls, there were some calls. So these bats were exiting the mine and flying around. So we thought we could use this to determine if they were remaining in areas of the state during winter. So some students helped us with these projects, and we put out acoustic detectors near rocky cliffs. And we ended up finding the yellow dots show presence in winter of northern long-eared bats flying near rocky outcrops in the state. So this gave us some evidence that maybe they're not all flying to the Black Hills or to eastern Nebraska to hibernate in the mines in eastern Nebraska or the caves in the Black Hills. Maybe some are staying locally and finding other hibernacula like rocky outcrops. But this didn't really prove that. We didn't know where they were actually hibernating. So we followed up with thermal cameras at a couple sites and recorded along with acoustic detectors to see if we could find bats coming out and where they were hibernating. And at the little blue site in southern Nebraska, we saw bats flying around these outcrops, even landing on them, but we didn't see them emerging from any cracks. But at Ponca State Park, we went there in 2017, we found a lot of calls near this big rocky, this opening in the rocky cliffs along the Missouri River. And we followed up with our thermal camera. So if you watch this site where the hand is right here in this video, so anything that has heat will show up as white on these thermal cameras. So if you watch that area, you'll see a little bat come out of the crack and fly around. And this was in late winter at Ponca. So I'll show that one more time. And so we had calls of northern long-eared bats and we had the video of them, but we wanted to confirm it. So we set up mist nets and you can see the poles outside this opening, and we captured 5 northern long-eared bats coming out of that opening, and they looked healthy. But when we swabbed them, all 5 were positive for the fungus. So this was in 2017, and that's why the red dot is up here in Ponca. So quickly, I'll finish with just talking about our summer surveys. And we had some good data at Fontenelle Forest down here before white nose syndrome arrived in the state, and up here at Ponca State Park based on acoustics and netting. So with students, we set up acoustic detectors at cliff sites at Ponca and also in the upland forest. And we set up detectors at Fontenelle Forest in both the floodplain and the upland forests before and after white nose syndrome. We also netted bats occasionally at these sites. And so when we put that together just recently, And we had about 3 years before white nose syndrome and 2 or 3 years after white nose syndrome. It was just extremely dramatic, the decline in the species. So the blue bars show acoustic activity, so mean number of bat passes of northern long-eared bats per hour, and the red that you can hardly see are after white nose syndrome. So if we look at Fontenelle Forest at both the lowland and upland sites together, there was a 99% decline in the species at these sites. And at Ponca, it was a 98% decline at Ponca. And so part of this we were interested in too, because we know some of the bats at Ponca use the rock crevices, and we thought, well, maybe they're more dispersed on the landscape, or maybe they won't spread the fungus as easily. Maybe the environmental conditions are different in these crevices, but the decline was just as sudden and severe at Ponca as it was at Fontenelle Forest.
I hate to cut you off, Jeremy, but we do have some questions in the chat. If you are able to answer those, I'm sure you can.
Yes, for sure.
Yeah.